Continuing preparation to discuss intermolecular forces, we now need to talk about molecular polarity. Molecular polarity always refers to the central atom of the molecule, and it depends upon two things: the bond polarity of each of the bonds to the central atom, and the molecular geometry of the central atom. A quick review on bond polarity. It depends on differences in electronegativity. It can be represented by a vector. The vector always points from the less electronegative element towards the more electronegative element, and we can see what the resultant value is after adding the vectors together. Molecular polarity, as I said, refers to the central atom. If the compound is a diatomic element, it will be nonpolar because there's no difference in electronegativity. If the compound has polar covalent bonds, but when you add the vectors up, they cancel out, you now have a nonpolar compound. Conversely, if you take a compound, add up the vectors from the polar covalent bonds, and those vectors do not cancel out, you now have a polar compound. How do you determine whether the vectors cancel out? You follow the steps. First step, draw out the correct Lewis structure. Second step, draw out the dipole vectors, remembering to draw from the lesser electronegative element to the greater electronegative element. Add the vectors together. If they cancel out, nonpolar. If they don't cancel out, polar. So let's take a look at a couple of examples. The first, is carbon dioxide polar or nonpolar? Follow the steps. Draw the Lewis structure. And because I'm only concerned about the central atom, here I did not draw in the electrons around the oxygens. Draw out the dipole vectors. There are two dipole vectors here, each starting at the carbon and then each pointing out to the oxygens, which looks like this. Now, because the two bonds are equivalent, the vectors should be the same length. Now we can add the vectors. So we line them up, and we see that they are of equal length but in opposite directions, so they cancel out. And because they cancel out, we can say carbon dioxide is nonpolar. What about phosphorus trichloride? Use the same mechanism. Draw the Lewis structure. Once again, just looking at the central atom. Draw out the dipole vectors, and you can see there should be three dipole vectors, each equivalent in length because the bonds are equivalent. Now we're going to add the vectors, and it should be pretty obvious that this vector and this vector are equal but opposite and cancel out. But there's nothing to cancel out this vector, so we can say the vectors do not cancel out here, and PCl3 is polar. And as a matter of fact, based upon the dipoles, the phosphorus has a slight positive charge, and each of the chlorines has a slight negative charge. Now you can generalize. If the number of bonding domains equals the number of electron domains, and all the outer atoms are the same, then the molecule is nonpolar. And here's an example of carbon tetrachloride. The vectors will cancel out here. However, if the number of bonding domains, the number of electron domains are equal, but one of the outer atoms is different than the others, then by definition the molecule has to be polar because the four vectors are not equivalent. The carbon-hydrogen vector is not the same as the chlorine-carbon vectors. So you can't get a total cancellation. This would be polar. If you have one non-bonding domain, then the molecule is going to be polar. Example, with a tetrahedral electron domain geometry, but a trigonal pyramidal molecular geometry, you can see that the three vectors will not cancel out here, and so the nitrogen ends up with a slight negative charge, the hydrogens with a slight positive. If you go to 5 electron domains, you can see that when you only have 4 bonding domains, once again the vectors will not cancel out. You end up with a polar molecule. If you have 2 non-bonding domains, then the molecule will be polar. But there is an exception to this. If you have octahedral electron domain geometry and a square planar molecular geometry, if the 4 corners of the square have the same element, then the molecule will be nonpolar. But if one of those atoms is different, then the molecule is polar. Now the classic is water. Water has a dipole where the oxygen is slightly negative and the hydrogens are slightly positive. Water is polar because it has a bent shape, which means the vectors don't cancel out. This is an excellent example of, in chemistry, function follows form. When you have 5 electron domains but 2 non-bonding domains, you end up with a T shape and the vectors do not cancel out. In a square planar, if all 4 of the corner elements are the same, the vectors will cancel out, as you can see here, and so that would be nonpolar. Linear molecules will be nonpolar if the 2 end elements are the same. If the 2 end elements are different, then the molecule will be polar. And it's nice to know these generalities, but if worse comes to worse, remember, if you draw out the Lewis structure and draw out the vectors, you should be able to deduce the polarity. So to review, molecular polarity refers to the central atom. Molecular polarity depends upon bond polarity and molecular geometry. If the vectors cancel out, the molecule is nonpolar. If the vectors don't cancel out, you have a polar molecule. Number of bonding domains the same as electron domains, and all the outer elements are identical, nonpolar. If the conditions are the same, but even one of the outer elements is different, the molecule is polar. If you have one non-bonding domain, the molecule will be polar. If you have 2 non-bonding domains, the molecule will be polar unless you have a square planar geometry, and that will be nonpolar provided all 4 elements are identical. If one of the outer elements is different, then the molecule is polar. For linear molecules, if the end elements are identical, nonpolar. If end elements are different, polar. Now, it's really important if you are asked why a molecule is polar or nonpolar, you must include a comment about the dipole vector. You can't simply say the element has a bent shape, therefore it is polar. The graders want to see that you understand that the vectors don't cancel. So if the molecule is nonpolar, you have to mention somewhere that the dipole vectors of the bonds add up to 0, or they cancel out, or draw it and show it, but you have to demonstrate you understand that. The same thing with the polar, you have to mention that the dipoles do not add up to 0, they don't cancel out, so on and so forth. So that takes care of bond and molecular polarity. In the next video, we'll start talking about intermolecular forces.